Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. And I'm pleased to welcome into the studio right now Dr. Dave from Ask the Naked Scientists. Good evening, Dave.
Good evening.
What's all new in the world of science for you?
Well, for a change this week, I thought I'd bring in an experiment.
Oh.
Because we've got a book out of experiments called Crisp Packet Fireworks, so if you're interested in science experiments, you can buy that. But I thought I'd bring you an experiment from it.
It's not going to blow up or be dangerous, is it?
This is a perfectly safe one. There are some which you probably shouldn't do in a studio in there, but this one's perfectly fine. For this one, I have a balloon and a tin empty drinks can.
An empty drinks can. Right, go on then, Dr.
So I'm going
Dave.
to blow up the balloon first.
Blow up the balloon. Ooh. It's a nice orange balloon.
Nice orange balloon.
Yeah.
I'm now then going to rub this on some hair. Now,
And you've got plenty of that, Dave.
I've got plenty of hair, but the hair on my head for some reason doesn't work very well.
Right.
The hair on my legs works a lot better.
Right.
So I'm going to get my leg up here. I'm going to rub the balloon on my leg.
Yeah.
Get it nicely charged up with any
Yeah.
of that.
Yeah. Okay.
Now if I put this near the tin can,
Yeah.
with any luck,
Oh.
without
Wow.
actually touching it, what happened?
The can moved along.
So you sort
It
of
moved. That was really good.
have a force
Oh, wow,
field.
it's still doing it as well.
The balloon is negatively charged now,
Yeah.
and a tin can conducts electricity.
Yeah.
So all the electrons which are negatively charged in the tin can are repelled by the balloon, so they move to the other side.
It likes your balloon.
So the side nearest the balloon becomes
Yeah.
positive, and it attracts the tin
Wow.
can, and it moves.
It does. Wow. Well, right, OK, we've got some questions lining up and getting ready. First of all, Dr. Dave, Andrew in Cambridge asks if all the Higgs bosons in a black hole accumulate to a super dense nucleus at the centre.
The simple answer to this is I don't have a clue. The more complicated answer is that a black hole is basically when you have a huge amount of mass in one place, and there's so much mass, and mass distorts space. And if you get enough mass in a very, very small space, it actually distorts space so much that light can't escape anymore. And the problem is that in these kind of conditions, all of the laws of physics we understand don't really work anymore. There's all sorts of things which don't seem to make any sense. So what's happening there, nobody really knows. I don't know, and I don't think anybody does know. Some people may have a better clue than me, but I'm afraid it's not. Really high energy physics is a bit beyond me, I'm afraid.
Now, Donna says, one evening last week, the moon seemed to glow orange and seemed a lot bigger than usual. What would have caused this, and does it happen often, Dr. Dave?
Normally when the moon, the size of the apparent size of the moon does change a very, very small amount, but it's only a couple of percent, because sometimes the moon is slightly closer to us and sometimes it's slightly further away. The apparent size of it does change a lot because of the way our brains work. So if the moon is low down, in front of lots of things which are a long way away, and we know are big, like houses and blocks of flats and trees, then our brain thinks, the moon is behind these big things which are a long way away, so it must be really big itself. But if it's up in the sky, you've got no sense of scale. And also, in our everyday life, things which are above, you don't see anything which is very far away above us. So you assume that it must be closer to you, so it must be smaller. So the apparent size of things is to do with how far you think they are away. So the reason why it seems big was probably just it was low down on the horizon. But the reason why it was orange was probably related with it being low down on the horizon. The sun often looks orange when it's low down on the horizon. This is because dust and the atmosphere tends to scatter blue light and green light a lot more than red light. So as if the sun is very low on the horizon, it's just skimming through an awful lot of the atmosphere. So it's going through a lot more atmosphere, so more of the blue and green light has bounced out. So all you're left is with the reds and yellows, so it looks kind of orange. And the same way, and the moon does exactly the same thing. The moon is coloured light. If it goes through the sun, it loses the blues and greens, so it looks slightly orange.
You can ask the Naked Scientists. On the phone now, ready for Dr. Dave. Here's Tony. Good evening, Tony.
Good evening, Sue.
What's your question for Dr. Dave?
Well, it's about carbon monoxide. Is it when gas burns, only when gas is actually burning it causes it, for a start?
Okay, carbon monoxide, if you burn carbon, it'll react with oxygen and form an oxide of carbon. Now, there are two different oxides of carbon. The one which is really common and much more stable is carbon dioxide, which causes slight problems with global warming, but that's pumping billions and billions of tons of it into the atmosphere every year.
Right.
Carbon monoxide is when it only partially burns and there's not enough oxygen. So you've got half as much oxygen for every carbon atom. And this is really quite reactive. One of the reasons why it's really poisonous to you is when you breathe it in, it actually sticks onto the hemoglobin in your blood in the same way that oxygen does, but it grabs on immensely tighter. So it locks on there and blocks up the hemoglobin in your blood, so your blood can't carry as much oxygen. The more carbon monoxide you breathed in, the less oxygen you can carry, until eventually you can't carry enough to survive, and you basically pass out. You start feeling sick first, then you pass out, and eventually you die.
Now I know that. Would it be possible, you can get the alarms, can't you?
Yeah.
Would it be possible to actually fix them to the boiler when the equipment is made, so if this happens, it turns the boiler off?
I see absolutely no reason why you shouldn't do. Seems like a very sensible idea. The only thing is that the kind of boilers which carbon monoxide are a problem with tend to be the very old ones.
The old ones,
because the modern ones are sealed, and if they are making lots of carbon monoxide, it all goes outside.
Lovely, Doctor. Thank you very much.
Thank you. Thank you, Tony.
Thank you, Sue.
Thank
Bye.
you. Bye-bye. Now, we have an email in. Hi, Sue and Dr. Dave. A couple of generations ago, the Americans had a device strapped to a man's back, possibly with a little propeller on top, which enabled him to take off and fly about. Why has this not become more universal and mass-produced? Was it just the cost? Michael Jackson had one of those.
Did he?
When he left the auditorium one time. Dave?
There are definitely people who are trying to build them. In fact, there's a couple of companies which are trying to build them at the moment. I forget their names. There are a couple of problems with it. One is the cost. I think they're looking at selling them for sort of $100,000 at least, so £50,000 or £60,000, which is quite a lot for have a little toy, basically. The other problem is they don't have very much range, so that the ones which they've built so far are all rockets, and because a rocket doesn't have to just carry a rocket works by throwing stuff downwards. If you throw something in one direction, it pushes you back. So if you throw gas downwards, it pushes you upwards, and you fly. Because the rocket has to carry both the oxygen and all the fuel and everything to throw downwards. You need to carry a huge amount of fuel to travel not very long. So they only last for 5 or 6 minutes, possibly, maybe 10 at the most. So they're very limited range. It's not very useful, really. It's quite a fun toy. They are thinking of building ones which involve jet engines, where you're just carrying the fuel, and jet engines then just push air downwards, which make them more efficient. Still not very efficient compared to even a helicopter and even much less efficient than a plane. And of course, there's the safety problems. If you're holding yourself up by a rocket which is pushing you upwards, or even a jet engine pushing you upwards, if that rocket or the jet engine fails, then you plummet downwards. If you push the buttons in the wrong order, then you can hit the ground very quickly. And it's all a bit dangerous, and I'm not convinced. I certainly wouldn't want to have a go on one.
Are you sure?
Yeah, I think I'd rather live longer than that.
Now, Kevin from Lowestoft says, Dr. Dave, is there any reason why, when they build offshore wind or wave farms, they cannot position them so they act as a breakwater, therefore easing coastal erosion, and the cost is met by the power companies? Dave?
Yes, I don't see why not. Basically, if you're putting up a wind turbine, you've put a big column into the sea, into the ground, and that would break up the waves a bit. It's going to act a bit like putting a mesh in front of the wind. It'll take some energy out of them. It'll be much choppier in behind, but there'll be less energy in the waves. There's no reason why it wouldn't work. I guess the big problem is where you want to build the breakwater is where you'll make a lot of money by putting out wind turbines. Because if it isn't very windy there, then there's no point putting the wind turbines up. And also, if it's a long way away from where there's something you want to protect, or a long way, if it's a long way away from something that needs power, or a long way away from a power cable, it's going to be very expensive to get the power from it. So, yes, another good idea. Although at the moment there's nothing to encourage the power companies to build the wind turbines somewhere useful like that.
Now, another question, this time from Keith. He asked if there has been or will ever be a conjunction of all the planets in the solar system. Dr. Dave.
Conjunctions are basically when you see more than one planet in a very small area of the sky. I'm not entirely sure exactly how close they have to be. I'm not sure if there's any reason why you shouldn't have all of the planets being... It depends how tight a conjunction you want. If you want them to get all over one on top of one another, I think that's going to be very, very unlikely, because all of the planets aren't quite in the same plane. So they're orbiting in roughly a plane going round and round in circles. It's like inside a piece of paper. But some of them are actually orbiting slightly above it, and some of them orbiting sort of angles slightly above, some angles slightly below. So I don't think they could all line up exactly with one another. I think it just depends how long you want to wait and how close you want them to be in your conjunction. What would limit it a lot is things like Pluto. I guess Pluto is no longer an official planet, but Pluto is orbiting at quite a big angle, is quite big ellipse, and slightly out of the plane of the solar system. So, yeah, I don't see why it's not possible, depending on how tight a conjunction you want to have.
If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast. If it is true that the human brain becomes, if the human brain becomes bigger, will we be less intelligent because of the time it takes for signals to go around the brain?
It's a very interesting question. Again, not really my expertise. It's definitely a problem with computers, that as you get, if you try and make a computer bigger and bigger and bigger, the time it takes for signals inside a computer only travel up almost, an electrical signal travels at almost the speed of light, but not quite. And the bigger it gets, the longer it will take a signal to get from one side of the computer to the other. So if you have a result of a calculation at one side of your computer which has to get to the other and then back again, then that can take an appreciable amount of time and slow everything up. Information moves around nerves quite a lot slower, so I guess it could definitely be an issue. I know that the size of brain in a creature doesn't necessarily relate very well to how intelligent it is. Because if you're good. If you're a very big creature, you've got to have lots and lots of nerves just running in your brain, lots of bits of your brain just running all of the nerves in your body, because you've got more muscle in your legs and more guts and more everything. Then you need more brain just to look after it and collate all those signals before the actual processing comes to. I'm sure definitely if you get to a certain size that would be an issue. I don't know what that size would be though.
We have an email in from Ian, and he says as a question, do you think, Dr. Dave, that the universe comes to an end and turns from black to something we don't understand?
There's all sorts of theories about how the universe comes to the end. In fact, there's quite an interesting, just why the sky is black is quite interesting in itself. Because if the universe went on forever and everything was staying fairly stationary, then if you went far enough, you'd always hit the surface of a star. So if that was the case, then the universe ought to be bright white and glowing incredibly brightly. But it's not, and it is black. And the reason for that is because the universe has expanded a lot. And so all the light, if you look in any direction far enough, you will see a star or you will see something that was glowing. But the light which has been emitted from that has been stretched so much that its wavelengths got longer and longer and longer. It's got redder and redder and redder. In fact, so far red that we can't see it anymore. It's gone down, right down into the microwave kind of wavelengths. It's been stretched so like millions of times. and so the universe was black. If the universe ended by collapsing again, then the sky would probably become white, because the universe is getting smaller and smaller and smaller. And in fact, instead of light getting stretched, it will start to get compressed and getting light brighter and higher frequencies, you'd be able to see it. So the sky would look bright blue, if not ultraviolet or X-rays. As far as we know, the present theories are that the universe is just going to carry on expanding forever, in which case it will just get blacker and blacker and blacker until you can't see anything at all.
All right, thank you very much. Paul on the A14 asks if the experiments bouncing protons or photons into each other at high speeds underground are dangerous to our planet.
Okay, I think this is talking about the LHC, which is crashing protons into each other. They had some slight setbacks. One of their magnets broke last week or so.
Really?
So they're having to warm it up, which takes about a month to fix the problem, then cool it back down again, which is going to take a month. So it's not going to start running again until next year. I think basically they're smashing these together with incredibly high energies, but the energies are still 1,000 times less than the protons which crash into the atmosphere naturally in cosmic rays coming in from exploding stars, probably. And they've been hitting the Earth for billions of years with energies greater than the ones which we're going to produce in the LHC. So odds are, and that hasn't destroyed the planet, so I think odds are that the LHC isn't going to. Very, very strongly they're against it.
Bobby Norwich has a question. He asks if putting polystyrene into plants' soil has any effect on eating the fruit.
I don't know. It's not my area of expertise at all. I guess the question is whether any chemicals from the polystyrene could leach out into the plant and then into the fruit. People do worry about some, mostly plasticizers, they're chemicals which are used to put in plastic, which make them more flexible. So it's possible that these chemicals could be affecting the way animals, and I guess humans, the way their hormones work, when they may be pretending to be hormones which they shouldn't be. But I really don't know. I would be surprised if they were getting from the soil into your fruit in very large quantities. But it's not my area of expertise.
I've got a very nice crop of tomatoes this year. I'm quite pleased with them. I just thought I'd throw that in as an added bonus, really. I would have
thought that the amount of these chemicals you're getting from that is going to be very small compared to the ones you get from just eating and drinking food, which have been inside plastic containers. And as far as we know, that's not dangerous.
It's not dangerous.
Well, some people, but some will always say everything is dangerous, but
yeah.
I haven't seen any evidence strongly pointing towards it.
All right, don't do that. It's dangerous. John sent me an email in a little bit earlier to say it's interesting, but what does Dr. Dave know about the hadron thingy that was going on? It's all gone a bit quiet. Is that the fact that they've broken the magnets?
Yeah. One of the magnets is damaged in some way. I don't know the specifics of how it has been damaged. They're superconducting magnets where they're made out of, I think it's a alloy of niobium, probably tin is a fairly common one. They cool them down to about 1.9 degrees centigrade above absolute zero, so about minus 271 degrees centigrade. And which means that they can carry a huge current and produce a very large magnetic field to bend the protons around the circles. The problem is that if they warm up to definitely above 4 or 5 degrees above absolute zero, they lose their superconductivity and they become a normal conductor. And so they've got a huge current flowing them, making an electromagnet. If it stops being a superconductor, that huge current just gets dumped in a very small area. It heats up lots. It boils off all the liquid helium, which they're using to cool it. And it doesn't work anymore as a magnet, and so they've got a problem with one of those. I'm not sure whether it did actually quench like that, but they're very, very they're difficult things to do. It's right on the edge of the present technology, and so yeah, it's going to take a long time for it to work anyway, to actually get results from the experiment. But it has broken for the moment.
We might spontaneously combust by then. Let's go to the phones once again. We have John on the line. Good evening, John. What's your question for Dave?
Dr. Dave, when I was a student studying automobile engineering, it was fascinating as a student trying to design an engine that would run on perpetual motion. And we always came up against the old chestnut of friction. Do you think we'll ever overcome that problem? And do you think perpetual motion will ever become a reality?
Well, perpetual motion is basically, it's sort of defined as you have an engine. Normally they're sort of machines whereby you have some kind of engine which converts energy from one type into another type and then back again into the first type, which can then get fed into your first machine. And so the energy is going round and round in circles. The real problem you run up against is thermodynamics. And, well, first of all, if you had absolutely perfect machines with no friction, then if you've got the simplest one would be a flywheel. You get it moving, it keeps spinning, and it would keep spinning for essentially forever. The problem is that then if you wanted to use that energy for anything, the flywheel will slow down, so you've got less energy, so it only really acts as an energy storage system. And all of the more complicated perpetual motion machines involve converting energy from one type to another, which actually loses energy and it gets converted into low-grade heat, which you can't do anything with. And so the amount of energy you got is less and less, even if it's not losses to friction. You can have all sorts of other kinds of losses. And it seems to be one of the really, really solid laws of physics that everyone's tried to break and no one has managed. It's been tested incredibly accurately, as far as we know, unless we find out something very, very, very weird at very, very strange parts of physics. As far as we know, you just can't. It won't work.
Okay, thank you.
John, thank you very much.
Bye.
Thank you. Bye-bye. Right. Sue has texted a question through to say, why do dogs lick you?
I don't know. My only thoughts on this subject is definitely dogs when they're puppies. They tend to lick the corners of their mother's mouth because if a dog in the wild or a wolf, the mother goes out hunting, gets some food, it can't really carry a whole carcass back. So one of the ways it carries food back for its young is to eat huge amounts of meat very quickly, fill up their stomach, and when it gets back to the babies, it regurgitates the meat, nicely chopped up, like baby food, really, to the young puppies. The puppies then eat the meat, and it's wonderful. And one of the ways they stimulate the mother to do that is by licking the corner of their mouth. So it could be sort of
to say they're hungry.
They're sort of associating you with their mother, and they want. Our dogs are always hungry. I'm sure they'll always.
Yeah.
So and it could be some kind of connection with that. I'm afraid that's the best I can do.
The best you can do. All right then. Okay. We'll let you leave it there. We have Ray on the line. Good evening to Ray. What's your question, Ray?
Well, the question is, in air, you go through a sound barrier at about 800 mile per hour.
Yeah.
Or something like that. Now, water being denser, sound travels faster through water.
Yeah.
What speed would you need underwater to break the sound barrier?
Sound travels in water at about 1,500 metres a second, which is going to be that's about 5 times faster than in air, so about 4,000 miles an hour, give or take.
That's if you could punch through the water.
If you could punch through water that fast.
Yeah.
If you're talking, it gets even faster.
My son come up with this question, and it intrigued me.
The speed of sound gets even faster when you get into solids. So if you're in rock, sound travels about 5 kilometres in a second. So again, about 3 times faster than in water. And I think one of the fastest materials it travels in is diamond, where it travels at about 11 kilometres a second. So about 30 times faster than in air.
Wow.
Basically, do you think that would be possible sometimes
to travel faster than the speed of sound in
water?
I don't know about travelling faster than the speed of sound. I think the fastest things travelling underwater are some really crazy Russian torpedoes, whereby they basically have a rocket-powered torpedo, and they right at the front of the torpedo is very blunt. This pushes the water out sideways, and so the torpedo is actually travelling in a bubble, so there's much less friction. But I think getting anything large travelling faster than the speed of sound in water for very long is going to require such a ridiculous amount of energy that I don't think we're ever going to do it. I don't think getting a human to do it isn't going to last. Then they're going to get very hot very quickly.
So the real answer is about 1,500 kilometres?
1,500 metres a second.
1,500 metres a second.
So about 1,500, so I think about 4,000 miles an hour.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.